Good morning, everyone. In this session, I am going to explain the concept of boundary layer, which is from the module 6. So let us see what is exactly meaning of boundary layer. So boundary layer is the region in the space or region above the solid surface in which the fluid velocity changes from 0 to free stream velocity u due to the viscosity effect. So basically the boundary layer, it is formed because of viscosity effect, and the boundary layer thickness, which is the delta, increases as the distance from the leading edge increases. So let us understand the concept of boundary layer with the diagram. So here I have taken one solid surface, which is the rectangular plate. So this is just an front view. So actually we have the solid surface like this. So this is one rectangular plate. And above this plate, so this plate is stationary, and fluid particles, that is the air, it is flowing over the plate. Okay. So for sake of understanding, let us imagine these are the air particles in a different layers. Okay. So initially, all these fluid particles, they have a uniform velocity. So in all the layers, velocity. So initially, air has a uniform velocity. This velocity is called the free stream velocity. So this is the concept of free stream velocity, which is the capital U. As the air flows over the flat plate or the solid surface, the layers which comes in contact with the solid surface, their velocity, it will reduce. And above this, the velocity will almost remain same. And this velocity is equal to the free stream velocity. Only at this layer, the velocity is reduced. Okay. So this is at the leading edge. This is the leading edge. At different section along the length of the plate, we can observe the variation of velocity from the bottommost layer to the subsequent layers. Now at this section A, section B, section C, and section D, we can see the gradual variation of velocity like this. And at a certain point, let us take this is that point. Above this point, the velocity remains same. And this velocity is equal to the free stream velocity. At the section B, this point, it will shift slightly like this. So below this, we can observe the variation. And above this point, we cannot see the variation. So velocity is constant. This velocity is equal to free stream velocity. So we can see there is certain point at different section. So if you join all these points, so we can see one region like this. So this region is called as a boundary layer. So below this dot, the velocity is changing because of viscosity like this. And above this, velocity is the same. That is a uniform velocity, which is called as a free stream velocity. So this dotted line, this is called as a boundary layer. That is a BL. Okay. So within this boundary layer, because of viscosity effect, there is a gradual variation of velocity. At this point, which is exactly at the boundary layer, the velocity u, so u means velocity at any layer, this is equal to 0.99 times the free stream velocity capital U. So this is the mathematical limit for the velocity at the boundary layer. Okay. Now if you observe here, this region of dotted line, it is gradually increasing. So this is the delta. At section A, this is the delta. At section B, this is the delta. So here you can see the boundary layer thickness. So delta means what? It is the boundary layer thickness. It increases as the distance from the leading edge increases. So this is the leading edge. So as the fluid particles moves over the solid surface, so this distance is x. So as the x increases, there is increase in the delta value. Okay. So this is the concept of boundary layer and the boundary layer thickness. So in a simple language, boundary layer, it is the region above the solid surface, means above this plate, in which fluid velocity changes from zero. So at the contact velocity, we can consider as a zero up to the free stream velocity due to the viscosity effect. Above the boundary layer, the viscosity effect is not significant, and therefore this velocity remains same. Okay. So here you can see in the animation how the boundary layer is developed from leading edge. So this is how the fluid particles moves over the solid surface. So you can see here there is a variation in the velocity. So this variation increases across the length. So at different section, we can see the variation of velocity, and this is the limit. This limit is called as a boundary layer. Below this, there is a viscosity effect. Above this, there is no viscosity effect. Okay. Now this boundary layer concept, it is used to determine the lift and drag on the aerofoil. So here you can see this is the wing of aeroplane. Okay. So this is the air particles that flows over that wing. So this air, it will create the boundary layer. So you can see here, these are the different sections, and this is the boundary layer like this. Okay. So because of this, it creates two types of forces. One is called as a drag force, and second is the lift force. So to determine this drag and lift, we need to study the concept of boundary layer. So drag means what? Because of air, this airflow will create the force in this direction, in the flow direction. So this force will try to push the wing of the aeroplane in the direction of the airflow. So this is called as a drag. The second force or the second component is the lift. So it will try to lift the aeroplane. So this is the wing of the aeroplane. One force will try to lift the aeroplane in the upward direction. Okay. So this force is the lift force, and second is the drag force. So to determine these forces Ft and Fl, we need to study the concept of the boundary layer. Okay. So this is basically the application. Now the next concept in the boundary layer is the displacement thickness. So what is displacement thickness? So displacement thickness, it is represented as a delta star. So it is the distance by which the boundary should be displaced to compensate for the reduction in the flow rate due to the formation of boundary layer. So just imagine we have two stationary rectangular plates like this, and the air flows between these two plates. So initially we have the uniform velocity for the air particles. As the air enters between this plate, the boundary layer is like this. So this dotted line is the boundary layer. It means that here this is how the velocity variation. So between this region, the velocity is a uniform. This is the uniform velocity. And for this region, there is a gradual variation of velocity. Okay. So because of the formation of this boundary layer, there is a reduction in the flow rate, that is the Q. Okay. So to maintain the constant flow rate, as the initial flow rate, we need to shift this boundary by certain distance like this. So the distance by which we should shift the boundary, this is called as a boundary layer displacement thickness. So this is the delta star. So mathematically, this is given by delta star is equal to, it is integration 0 to delta in bracket 1 minus u upon capital U, which is the free stream velocity, into d1. So this is the mathematical equation for the displacement thickness. Next, we have the concept of momentum thickness. So it is similar to the displacement thickness. Momentum thickness is represented as a theta. So definition is, it is the distance by which the boundary should be displaced to compensate for reduction in the momentum due to formation of boundary layer. Okay. So just I will give the mathematical equation for the momentum thickness. So it is theta is equal to integration 0 to delta. It is u upon u in bracket 1 minus u by u into d1. So this is the equation for the momentum thickness. So both these formulae, they are required to solve the problem on the boundary layer. So in the next video, we will see how to solve the problem on the boundary layer.